now solving basic logarithmic and exponential equations. So to solve these basic kind of equations, the rules are, again, remember, log base a of x is true if or only if a to the y equals x. Sometimes that's helpful to know that. Check the values that are in the domain. Again, logs can only take on positive values. You always have to check logarithms. You don't have to check exponentials. Those are fine. Now, give exact answers and approximate answers to 3 decimal places. Sometimes the exact answers are messy, so we'll give both the exact and the approximate to 3 decimal places. So the first thing you want to do is make sure that the log term and the exponential term are solved on one side of the equation. That means you've got one log term on one side and one number term on the other side. Use the uniqueness property and the inverse properties to unbury the variable terms, right? Then solve for the variable expressions. All right, so we're going to use that last property we talked about in the previous video and the inverse properties. All right, so the first example here, and I'm going to rewrite it over here so that I can, if I've got 10 to the x equals 7, so most of these will already start out where I've got one log term and one exponential term. Alright, so I've got my so these are all exponentials, and then we'll do logs in a second. So we're going to start out with exponentials because they typically are easier for students. Right, log base 10 of x equals 7. So there's 2 ways to do this. Right? You can either use the uniqueness property or rewrite it as its logarithm. I actually think the uniqueness property is the easier way to go, so that's what I do. And so what I want to do, well, I need to get rid of this 10. Right? I need to get to x. I need to get rid of the 10 to get it. Well, in order to get rid of the 10, well, if I take the log base 10, which remember, you can just write that as log, the 10 will cancel out with the log base 10. Alright, well, whatever I do to one side, uniqueness property, whatever I do to one side, I have to do the other, so that's also the log of base 10 of 7, which I can plug that in my calculator. And so again, the 10 and the base 10 cancel out. On this side, I'm left with x. X is exactly the log of 7, so that's exactly, so there's my exact answer. And then to find the log of 7, I'm going to round. There's a log key on your calculator. You should be able to locate the log. It's the log. So you type log of 7, and it should give you out 0.845 if I round 3 decimal places. Alright, the next example. Which I'm not sure if I've given myself enough room to work these, but I will. Alright, so my next example is here. And so it's 2 equals e to the x, which again, it's already isolated the x term, right, which is e to the x, and the 2 on the other side. So I need to get rid of the e part. Well, I need to take its inverse. Well, the opposite of the e is the log base e, right? Log base e, which we can write as the ln. Alright, so I want to take the natural log of this side, of e to the x. So whatever I do to one side, I have to do the other. So the other side, I'm also going to take the natural log. I do that because the natural log and the e are inverses. This is the inverse property. They're going to undo in another, leave me with x on this side. X is exactly the natural log of 2. Alright, then I plug the natural log of 2, and again, it's the capital ln on your calculator. Some calculators have the lowercase, some calculators have the capital. So find ln on your calculator. Should be right around the log place, and type in 2, ln of 2. It should come out 0.693 if I round 3 decimal places. 693. It's exactly the natural log of 2. Right, which again, I could check it out. 2 equals e to the natural log of 2. Well, that's true, right? Because the e and the 2 leave me with 2 equals 2. I digress though. Alright, the next example. 2 to the x equals, in this case, square root of 8. You could probably solve this by hand. This is actually one that we did earlier in the beginning. But I'm going to use my logarithms. Alright, so I'm going to take my log base 2 of both sides. So log base 2, log base 2. On this side, I'm going to be left with x. On this side, I have a log base 2 of the square root of 8, which some calculators have it where you could type in the log base 2 of a function. But not all calculators, it's easy to find, so I'm going to use my change of base formula so I can plug it in my calculator. So I'm going to use the natural log of the square root of 8 divided by the natural log of 2. Those are exactly the same. That's using my change of base formula. Alright, so log base 2 of the square root of 8 is exactly the same as the natural log of the square root of 8 divided by the natural log of 2. If you do that, it should come out 1.5 or 3/2. So my x value is 3/2. And that one I don't really need to round because it's exact. Alright, same thing for the part D here, is I could solve this like we did earlier. Right? But I'm going to solve it using my logarithm. So 0.00, make sure I get enough zeros. So it's base 10, so I'm going to take my common log of both sides. So common log of both sides. So common log of 0.0001 equals x, right? That's exactly what it is. And this one actually simplifies really nice. If you take the log of 0.0001, that should come out -4, right? 10 to the -4 equals 0.0001, and that's true. Alright, next example. Alright, this one I have to do a little work before I get started. So the first ones were pretty straightforward. They are already isolated, and I just had to use my uniqueness property and my inverse property. Right, this one I have to do a little work. The little work is I have to isolate the term. Right, so first thing I have to do is move the 5 over, so I get 100 equals 10 to the x. Again, I could solve that without typing it into the calculator, but I'm going to go ahead and use the uniqueness property. I already know the x value should come out 2, but if you use the this kind of shows you that the property works. If I take the log base 10 of both sides, here I'm going to be left with x. If you take the log of 100, you type in your calculator log of 100, it will give you out 2. Alright, next example. So again, I have to isolate, so divide by my 4. So I get 3x equals 10 over 4, which reduces to 2.5. I'm just going to write it as 2.5. Take the log base 3 of both sides. So I get x on this side. This is the log base 3. And if you have a calculator, it's easy to get to where you can change your bases. You can, I think on our graphing calculator, it's not. It's easier to find the log and the natural log. So I'm going to go ahead and use my change of base, right? X is log base 3 of 2.5. In order to type that on my calculator, I'm going to use the change of base, which is, my rule of thumb is natural log. But if you use log base 10, that's fine too. So it's natural log of 2.5 divided by natural log of 3, or log of 2.5 divided by log of 3. You should get the exact same x. That's what x is exactly. And then the approximate is 0.834. Let me double check that. Make sure it is 0.834. So natural log of 2.5 divided by natural log 3. Yep, comes out to 0.834 if I round 3 decimal places. Alright, the next example, which I believe is the last one of the exponentials, and then we'll get into the logarithms, which I'll probably stop the video and pick it up in the next one. Right, first thing though, isolate the term, so move the 2 over, so I get 5 e to the x equals 18, divide by my 5, e to the x equals 18 over 5. Take the log base e, which is the natural log, right? Natural log is the log base e. Those two things undo each other, leave me with x. X is exactly the natural log of 18 over 5, and then you can type in 18 over 5 into the calculator and give you your approximate answer. So it's the natural log of 18 divided by 5, which comes out 1.281 if I round 3 decimal places. Right, so that finishes up solving the exponentials, basic exponential equations using logs, and now we'll solve logarithms using exponentials. Sorry about that noise, guys.